Hi guys, this is Andrew. I am one of the practicum students that is with your class this semester. Today I'll be going over a second video in the folder. This video will be about other infinite sequences and series that we've not talked about, those being geometric and arithmetic that we've already talked about. These ones will be a few others that are related but also unrelated. This video will be notes and also an example problem or two, along with talking about the homework problems. So we'll start with the objectives for today. Today's first objective is to define several other infinite sequences and series in terms of what they are, the rules behind them, and then to give us some examples of those, as well as to identify the sequence and series type based on several consecutive terms that are given to us. So just a short little review here about sequences and series. A sequence is a set of numbers that are related to each other in some way, shape, or form. And then a series is simply the summation of all the terms in that sequence. So if we look at the examples on the board here, the sequence on the left is just a set of numbers that are related to each other. These ones are all the odd positive numbers. Versus a sequence is the summation of a series. This one is the inverse powers of 2, all added together into a single summation. So the first type of different sequence / series we're going to go over is the harmonic. A harmonic sequence is related to the arithmetic sequences in that each term of a harmonic series is a reciprocal, or sort of like the flipped fraction form of an arithmetic sequence term. And then again, a harmonic series is just the summation of all the terms in a harmonic sequence. So to start off with our first example here, we have the arithmetic sequence and series of 1, 2, 3, 4, 5, and so on, or 1 plus 2 plus 3 plus 4 plus 5, and so on. This is just the basic counting numbers that are greater than 0, so when you count, you go 1, 2, 3, 4, 5. That's what this is. So the harmonic series of those is right here. As you can see, it is the fraction form of these. If you were to take each of these and do 1 divided by the first term, gives you the first term of the harmonic. 1 divided by the second term will give you the second term of the harmonic series, which would be 1 over 2. Then we would have 1 over 3, 1 over 4, 1 over 5, and so on. And then the harmonic series would just be the summation of that, so we'd have 1 plus 1 half, plus 1 third, plus 1 fourth, and plus 1 fifth. Basically, the thing to remember is just that this is like the opposite of a arithmetic sequence. So if you could flip the numerator and denominator of every term in a harmonic series, it would be a arithmetic sequence. Or if you have an arithmetic sequence and you flip the numerator and denominator of each term, it's the opposite. It becomes a harmonic series. Now let's look at a second example here. On the left here we see we have all the even numbers greater than 3. So we have 4, 6, 8, 10, 12, and so on. The summation of those again is just 4 plus 6 plus 8, and so on. And then the sequence for that would be 1/4, 1 over our first term, which is 4, and then 1/6, 1 over our second term, 6, 1/8, 1 over the third term, which is 8, and so on and so forth. And then the series is just adding all those terms together. And then the second and final type that we're going to go over today is alternating sequences and series. So an alternating sequence is a sequence of numbers where the terms will alternate between positive and negative numbers. An alternating series is the summation of all terms in such a sequence. So one note to make here is that when we're looking at these examples, the first example shows just simply one number that's alternating back and forth between positive and negative. It starts at 1, then it's -1, and then back to 1, back to -1, back to 1, and this will continue on forever. The summation of that is just 1 plus -1 plus 1 plus -1 plus 1, and so on. And then another series could be, if we were to use this same type of thing with the odd numbers, we would have 1, -3, 5, -7, 9, and so on. And the summation is just shown there. And the important note to make about this is that these do not have to start with a positive number, but typically will. This could be a negative number, and then the second term could be a positive number, but typically you'll still have where it alternates, where one term will be positive and the next will be negative, or vice versa, where one term will be negative and the next one will be positive. Either way, it's still an alternating series, and it's called alternating because it's, again, alternating between the sign. The sign is alternating between positive and negative. Okay, and then to look at one of your example problems, this problem will be on identifying sequences and series by type. The problem itself, wording-wise, will be to identify what type of sequence or series each of the following is based on the given terms. So the important thing for you guys to note about this type of problem is that, one, it can be a sequence or series. So you need to make sure you're looking for either the curly brackets or you're looking for pluses in there. Those will identify each of these basically. And then to note there are 3 different terms we can have for these, as well as you have to obviously identify if it's a sequence or series, but the first is harmonic of a type, second one is alternating, and then the third is arithmetic, which is technically not in this video, but it is from the first part of this unit. And apparently I can't spell arithmetic, but you guys get the point. So how you go about doing this type of problem, I will give you the information that each of these is only used once here. On the actual homework, you are given a few more terms than this, and they can each be used more than once. So for this first problem, what we'll be looking at is first we identify that this is curly brackets right here. So that means that this is a sequence. Secondly, we have to look at, well, if we're looking for, I think the easiest one to identify first is the alternating sequence or series. So if we see all positives or all negatives, we know it's not that. But since we see here it's positive and then negative, positive and then negative, positive and then negative, we know that this is an alternating sequence. So then for the second problem, right here we have 1 plus 2 plus 3 plus 4 plus 5. So the remaining answers we can use for here are harmonic and arithmetic. I think if you want to try to figure out if it's all arithmetic or harmonic here, you can start by just looking at this, trying to find if there's a common difference. So we'll just draw these arrows real quick and then look and see if there's a difference. And 2 minus 1 is 1, and then 3 minus 2 is 1, 4 minus 3 is 1, and then 5 minus 4 is just 1. So that means that we do have a common difference, which means that this is arithmetic. Additionally, what I didn't note already is that these have pluses in between them, which means that this is a series. And then last but not least, process elimination kind of tells you what this is. First off, we'll look again at the pluses. So we have plus, 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 and so on. So this must be a series. And then secondly, we have to look at the we have to look at the terms in here. One thing I like to look at them is if we look at these bottom terms. So if I were to compare those two bottom terms and then the next two bottom terms, so on and so forth, we would have 2, 4, 6, 8, 10. So then the differences here would be 2, 2, 2 again, and then finally 2, which means that because we have a common difference in the denominators, it's actually the opposite of arithmetic, which means that this must be harmonic right here, so this must go down here. So again, guys, just the common ways that I've been looking at these to identify which one is which is to first off, when you're looking for a sequence or series, look for the brackets and then or the pluses as noted up here. And then secondly, look through the series, see if you have the alternating pluses and minuses. That'll identify an alternating series. And then if you're looking for the harmonic or arithmetic, typically harmonics will be in fractions, and then arithmetics will not be in fractions, although the vice versa could be true. But if you can look at any of them and see if there's a common difference between them, and there is arithmetic, if there's no common difference, then it must be harmonic, but you still want to double check that it is harmonic by looking at the differences between the decimals. Okay, so then just look at your related homework problems here. You'll see that you have a couple more problems involved in this. But what you have to do again is you have to use the given terms in a sequence or series to identify whether you have a sequence or series, and the type. And then additionally, you can use the word bank that is given here, containing the harmonic, alternating, and arithmetic sequences and series for each of these. And then note is that each term may be used more than once, but the hint is that each term is used at least once. There's just 3 terms that are repeated throughout the thing. So all you guys have to do for one of these, and I'm not going to give you the exact answer for one of them, but again, is to just identify what it is. Again, show some work, either circle some stuff on it or just highlight something in it. Let's say, for example, you were going to look at this first one, which we'll just do together real quick. Basically, to identify the sequence, you could circle these curly brackets, and then you would know it's a sequence. You could then underline maybe these things right here, and then find the difference between the denominators, and then you would find that you have plus 3, and plus 3, which tends to mean that this is a, I'm going to write harmonic sequence. If you guys can read that handwriting. Basically, just to circle it to make it a little more clear, it's this one right here. It could be in another one as well. I don't actually remember which ones are which at the second here, but some of them are used more than once. Harmonic series may be one that is used more than once. You guys have to look and figure that out for yourselves in the unit. So just a quick reminder and wrap up here. Remember that this is the homework that I just showed you is part of an assignment about infinite arithmetic series and other series assignment. So just make sure you guys complete that for this week. Also make sure to do the geometric sequences and series material, as well as the infinite geometric series material that is in this week's folder. And then all this is in prep for a test that is also being done this week. So just make sure you guys are getting all that stuff done. If you have any questions, make sure to attend one of the ASCs or one of the office hours to talk to myself or Miss DB.